At the end of May 2020, 10 million people were glued to the screen, closely watching as SpaceX's rocket was about to launch into space. In mere minutes, the rocket dashed into the open space. Millions of people watched in excitement as the rocket left the atmosphere on a mission. This was one of the largest space events that anyone could watch from their devices and witness yet another achievement of the human race. We've come a long way from starting a fire to launching rockets into a never-ending universe that we have yet to discover. This is the story of how rockets became the pinnacle of human civilization. It will sound strange, but modern rocketry as we know it has its roots in China's 1st century AD. During ancient times, Chinese soldiers had a new wonder weapon that worked perfectly against large hordes of their enemies: fireworks. They were made of hollow tubes filled with saltpeter, sulfur and charcoal. When it lightened up, it made a really loud noise and a bang, which scared the souls out of the enemy rather than doing any damage. The technology was carried further into the 13th century when the Battle of Kekeng occurred. The Chinese soldiers managed to repel the attacks of countless Mongol hordes by shooting the arrows of flying fire at them. These were nothing but rudimentary, solid-propelled rockets filled with powder. But the story doesn't stop there. In the late 18th century, during the existence of the Kingdom of Mysore, soldiers developed a new type of rocket weapon. It used sturdy iron tubes to launch explosive projectiles at an impressive 3-mile range. The weapon was so impressive that an Englishman, William Congreve, designed a rocket based on them and adopted it to the British Army. The first use of this weapon was documented in 1812 during the War against America, which declared independence from the British Empire's rule. Although rockets were a great weapon to cause as much damage as possible, they were quite inaccurate. Since they had no guiding system and could backfire, they were replaced with more sophisticated weapons such as guns. They are far more accurate and can cause damage more effectively. However, rockets weren't going to become a thing of the past. Instead, people found a new purpose for them other than signaling and celebrating events. One of those pioneers who was inspired by rocket technology was Konstantin Tsiolkovsky, a Russian scientist. In 1903, he published a refined iteration of the rocket equation, made by William Moore back in 1810 to popularize it. The equation states that it sets out the relationship between rocket speed and mass, and how quickly gas exits the propellant system to achieve lift. One of the most important things he noted in his work was the relationship between fuel and speed. It's exponential, meaning non-linear. In simple terms, if scientists want to double the velocity of the rocket, simply doubling the fuel won't do the trick. He also described the shape of the future spacecraft, an elongated metal shape with the least resistance, equipped with electric light, oxygen, and means of absorbing carbon dioxide. At the narrow end of the tube, explosives are mixed. This is where the dense burning gases explode outward into space at a tremendous velocity, ascending further into the skies. Although Konstantin gave a meaningful boost to rocket science in his motherland, the other side of the planet had its own bright minds who led the rocket revolution. One of these revolutionaries was Robert Goddard, an American scientist. In March of 1926, he applied his rocket equation and tested it in practice. Even though liquid fuel rockets had been tested on the ground, Goddard's rocket became the first to successfully achieve powered flight. But it wasn't one of those big ones, no. Goddard's rocket was just a 10-foot cylinder. However, during its flight of 2.5 seconds, it reached an altitude of 4 feet and crashed 184 feet away from the launching frame. This was just one of his many experiments to find the best way to launch rockets. After one of those experiments, he concluded that combustion should happen in small chambers, separated from the primary fuel. He also noted that rockets would need to be arranged in stages. It's important to note, that Johann Schmidlapp, a German scientist who also launched his own mini rocket, served as an inspiration for his work. It burned all the fuel to get as high as possible. And then the rocket burnt the second projectile to fly even further. However, the Romanian scientist Hermann Oberth, who worked in Nazi Germany during the Second World War, made the first real significant progress in rocket science. Just not in the way you'd expect. After publishing a few of his works on rocket technology, a young man, Werner von Braun, applied to become his apprentice and was gladly accepted. The thing is, his task wasn't to design a rocket that would launch people into space. He worked on developing the first functioning rocket, the German Aggregate 4, also known as the V2. Some of you already know where this is going. It wasn't just a rocket, it was the world's first ballistic missile, used against the Allied forces and during the bombing campaign against Great Britain. Being 45 foot tall, it created a huge thrust by burning liquid oxygen and alcohol at the rate of around a ton every 7 seconds. It could reach outer space and quickly come down on a target. There were no possible ways to detect and intercept a missile at the time, and it caused huge damage to the country. However, even this Wunderwaffe didn't help Nazi Germany win the war. After the regime was toppled, both the United States and the Soviet Union conducted special operations to hire German scientists to assist in developing their respective rocket programs. This was one of the most important parts of the Cold War, dominance over space. Both countries were doing their best to gain the upper hand and become better than their adversaries. The United States, with all its scientists and blueprints, created the SM-65 Atlas, the first operational intercontinental ballistic missile, which only raised the tension. But the Soviets were not eager to quit. They created the R-7, a two-stage rocket capable of traveling 5,000 miles. It became the workhorse of the Soviet space program for half a century and underwent many upgrades and improvements. Massive projects were launched using this rocket, such as the first man-made satellite, Sputnik, and the first man in space, Yuri Gagarin. The first rocket that launched and delivered the crew of 3 astronauts to the moon, and a space shuttle. Needless to say, these years were wild. Maybe this competition between 2 nuclear rivals was for the better after all. In the present day, the space race continues. The superpowers of the modern world are continuing the development of their space technologies and planning new journeys to the moon. It's fascinating to see how far humans have come, from firing fireworks to launching rockets into space to exploring the vast universe. Maybe one day we will be traveling from planet to planet. Who knows, right?